Hi everyone, this is Professor Oaks, and in this video we are going to discuss adding and subtracting radical expressions. So let's look at this first one here. We have 10 times the square root of 27 minus 5 times the square root of 48. So we have to look at this the same way that we would look at something simpler like 10x minus 5x. These would both need to be the same variable before we could actually subtract these. So that's what we call like terms. So when you are adding and subtracting radical expressions, you need to have like radicals, and here you see one of these is square root of 27 and one of these is square root of 48, so we can't actually subtract these. So let's go ahead and simplify each of these square roots here. So I know that 27 is square root of 9 times the square root of 3, because 9 times 3 is 27. And I know that the 48 is going to be, all right, so what is that going to be? That's going to be 16 times 3, because 16 times 3 is 48. Then the square root of 9 is 3, so 10 times 3 times the square root of 3. And the square root of 16 is 4, so 5 times 4 times the square root of 3. So 10 times 3 is 30, so 30 square root of 3. 5 times 4 is 20, so 20 square root of 3. And now you see that these are like terms, or terms with the same radical. All right, so if I have 10 square root of 3 as my final answer here, and again, that's because I have 30 minus 20. All right, so 30 square root of 3 minus 20 square root of 3 is 10 square root of 3. So let's try another one here. So we have 4 square root of 24 plus 3 square root of 150. So now I see that these are not like radicals, so I need to see if I can simplify these in order to be able to add these together. And I see that, well, 24 is 4 times 6, and I see that the 150 is 25 times 6. So square root of 4 is 2. So I have 4 times 2 times square root of 6. And square root of 25 is 5. So I have 3 times 5 times square root of 6. Then 4 times 2 is 8. So 8 square root of 6. 3 times 5 is 15. So 15 square root of 6. And now I see that these are the same radical here. So I can add these just like up here, how I did 30 minus 20, I'm going to do 8 plus 15, and that will give me 23 square root of 6. So there is my final answer. What a time to be alive. All right, so let's try another one here. So we have 2 square root of 320 minus 2 square root of 125. So something similar to what I have done before. I look to see if these two radicals are the same, and they are not. So what am I going to do? I'm going to try to simplify each of these square roots. All right, so I know that 320 actually is 64 times 5, and then 125 is going to be 25 times 5. So then the square root of 64 is 8, so I have 2 times 8 square root of 5. And the square root of 25 is 5, so I have minus 2 times 5 square root of 5. And now 2 times 8 is 16, so I have 16 square root of 5 minus 2 times 5 is 10, so 10 square root of 5. And now these are like radicals here, so they're both square root of 5, so I can just subtract 10 from 16, so 16 minus 10 is 6, so I have 6 square root of 5 as my final answer right here. All right, what a time to be alive. So now, here are some more complicated ones here, because we're bringing in the variables now. So I have 4x squared, square root of 72x to the 11th, plus 10x square root of 32x to the 13th. All right, so now let's just go ahead and look again. Are these radicals the same? And they are not, so I have to simplify them both. All right, so I'll just look at the 72 first. All right, so if I do that, then I have 4x squared, and then I know that 72 is actually it's going to be 9 times 8, so 9 times 8 is 72. And then remember, for these square root of x to the 11th, because this is a square root here, the index of this radical is 2. I take the 11 and I divide it by 2, and I get 5 with the remainder of 1. So this means that it's x to the 5th, and then one of the x's stays on the inside. So x to the 5th square root of x. All right, so this is x to the 5th square root of x, and then plus 10x, and then the square root of 32 is actually going to be, well, what is that going to be? Well, all right, so that will be, well, let's look at this. All right, that will be 16 times 2. All right, that's 32. And then the square root of 13, square root of x to the 13th here, I take the 13 and I divide it by 2. That will be 6 with a remainder of 1. So I have x to the 6 and square root of x to the first. So x to the 6 and square root of x. Now, I know that the square root of 9 is going to be 3, so I have 4x squared times 3, then the square root of 8, and then x to the 5th square root of x, then plus 10, x square root of 16 is 4, so times 4, square root of 2, x to the 6th square root of x. And then I see here, and I might have maybe caught this sooner, but it doesn't matter because you can always fix this. You see that there's still square root of 8 and x under the square root in this term, and square root of 2 and x under the square root in this term. Well, that means that they're not alike, but that doesn't mean that I am wrong either, because square root of 8 is actually going to be, all right, so that will be square root of 4 times square root of 2. And then I have still all of these other items over here, all these other factors over here. And then square root of 4 here is 2, so I have 4x squared times 3 times 2 times square root of 2, x to the 5th square root of x, plus 10x times 4 square root of 2, x to the 6th square root of x. So now, in the first term, I see that all I have under the square root now is square root of 2x, and here square root of 2x. And so what I'm going to do is just say, well, now, yeah, they're both the same radical now, square root of 2x in each term. So I'm going to multiply the rest of this together. So 4x squared times 3 is 12x squared times 2 is 24x squared times x to the 5th. That will be 24x to the 7th, and then square root of 2x plus 10x times 4 is 40x, and then times x to the 6 is 40x to the 7th, so 40x to the 7th square root of 2x. So then these are the same radical here, so I have square root of 2x, and then I can just go ahead and do the addition here. So 24x to the 7th plus 40x to the 7th is 64x to the 7th. And that's what I have right here. There's my answer. What a time to be alive. All right, so let's try another problem right here today. So hopefully this is something where you feel like you could get the hang of it fairly easily. So let's look at another one here. We have 4a and square root of 176a to the 9th minus the 5a squared square root of 99a to the 7th. All right, so what are we going to do here? Well, we have to do the same thing as before and just realize that these are not the same radical. So we are going to simplify the square root. So we have 4a, and then the square root of 176 is actually 16 times 11. And then for the square root of a to the 9th, we know that 9 divided by 2 is actually 4 with the remainder of 1. So we have x to the 4th square root of x minus 5a squared. Square root of 99 is square root of 9 times square root of 11. And then the a to the 7th, we have 7 divided by 2 is 3, remainder of 1. So this gives us the square root of a to the 7th is a to the 3rd square root of a. And you know what? I wrote x instead of a, so that's okay. I can change them to a, right? And so now I can go ahead and just simplify. The square root of 16 is 4, so 4a times 4 square root of 11, a to the 4th square root of a minus 5a squared. Square root of 9 is 3, so times 3 square root of 11, a to the 3rd square root of a. Then I look at each of the terms and see if they have like radicals now. So this is square root of 11a, square root of 11a, and so they are the same here. So let's just go ahead and multiply the rest of the factors in each term together now. So 4a times 4 is 16a times a to the 4th, that's 16a to the 5th. So I have 16a to the 5th square root of 11a minus 5a squared times 3 is 15a squared times a to the 3rd is 15a to the 5th minus 15a to the 5th square root of 11a. And now I see that these are the same radicals here. So I just go ahead and I am going to do the subtraction. So 16a to the 5th minus 15a to the 5th is 1a to the 5th, or just a to the 5th, and then square root of 11a. So there is my answer right there. What a time to be alive. All right, let's try another one here today. So we have 3st squared, square root of 243, s to the 11th, t to the 9th, minus s squared, t to the 3rd, square root of 108, s to the 9th, t to the 7th. All right, so now we see that these are not the same radical. So now I need to go ahead and simplify these here. So I see that we have 3st squared, and square root of 243 is square root of 81 times square root of 3. Then for s to the 11th, 11 divided by 2 is 5 with the remainder of 1. So I have s to the 5th square root of s, and then t to the 9th. Well, I know 9 divided by 2 is 4, remainder 1. So we have t to the 4th square root of t, then minus s squared t to the 3rd, and then 108 will give us the square root of 108 will be square root of 36 times the square root of 3. Then we have s to the 9th, so that will be, well, that will be s to the 4th square root of s, and then for t to the 7th, we will have, well, since 7 divided by 2 is 3 with the remainder of 1, all right, we have t to the 3rd square root of t. Now I will go ahead and simplify the square roots that I can. So I have square root of 81 is 9, and square root of 36 is going to be 6. All right, so I have 3st squared times 9, square root of 3, s to the 5th, square root of s, t to the 4th, square root of t, minus s squared t cubed times 6 square root of 3, s to the 4th, square root of s, t to the 3rd, square root of t. All right, now I look at each term and see if they have like radicals now. So square root of 3st, square root of 3st. There we go. So they are like radicals. So now I just go ahead and I am going to just simplify this here. So let's do that today. All right. So s times 3t squared times 9 is 27st squared times s to the 5th, so at 27s to the 6th t squared, then times t to the 4th will give us 27s to the 6th, and t to the 6th square root of 3st minus, and then s squared times t to the 3rd times 6 times s to the 4th times t to the 3rd will just be the 6 s to the 6 t to the 6 square root of 3st. And now, since these are are like radicals now. We just subtract the the terms. All right, so 27 s to 6 t to 6 minus 6 s to 6 t to 6 is actually 21 s to 6 t to 6. So this is 21 s to 6 t to 6 square root of 3 st. All right, there's the answer. What a time to be alive. All right, let's try another one here today. So we have, what do we have here? We have the cube root of 9 times the cube root of 6 plus the cube root of 27 times the cube root of 16. All right, so what do we have here? Well, this one might seem a little bit trickier than you might think, but if I look at this, I can't do the cube root of 9 and I can't do the cube root of 6, but I can do cube root of 27. That is cube root of 3 times 3 times 3, because that's what 27 is. So then I know this is cube root of 3 to the third power, which is just 3. All right, and then the cube root of the 16, well, 16 is 2 times 2 times 2 times 2, right? So then I know that here I can bring out 2 to the first, so because I have a group of 3 2s, so it's 2 times the cube root of 2. All right, so what do I have here? Well, like I said, I can't break down the cube root of 9 because I don't have 3 3s under the cube root, and I can't break down the cube root of 6 because I don't have 3 2s or 3 3s under the cube root. All right, so then this becomes the cube root of 9 times the cube root of 6, and then plus cube root of 27 was 3, so 3, and cube root of 16 was 2 cube root of 2. So now I'm going to combine these by just multiplying them, all right? So the cube root of 9 times 6 is actually cube root of 54, and then 3 times 2 is 6, so 6 cube root of 2. Well, now if I look at this, I might be able to do something, because cube root of 54, well, that is cube root of 3 times 3 times 3 times 2, and plus 6 cube root of 2. And now I see I do have a group of 3 3s here, and I could have saw that up here when I broke down the 9 and the 6 separately, that there was 2 3s and there was 1 3, all right? So I actually did more work by multiplying it and making it 54 first. So now I already realized that this will be 3 cube root of 2 plus 6 cube root of 2, and now these are both the same radical. So 2 under the cube root and 2 under the cube root. So 3 cube root of 2 plus 6 cube root of 2 will be 9 cube root of 2. All right, so 3 plus 6 is 9. So 9 cube root of 2. There is my answer. What a time to be alive. All right, let's try another one here today. So we have cube root of 375 minus 2 cube root of 192. So 375, can I break down that cube root here? Well, yeah, I definitely can. That will be cube root of, all right, what will that be? 3 times 5 times 5 times 5, and then 192 is going to be, well, that will be 3 times, what will that be? 2 times 2 times 2 times 2 times 2 times 2. All right, so there you go. So that will be 192. And you can multiply those to make sure that I'm right and I'm not trying to scam you here. And remember, this is a cube root, so I'm looking for groups of 3. So here's 3 5s and 3 2s and 3 2s. So I can bring out a 5. So 5 cube root of 3 minus 2 times, bring out a 2. So 2, and bring out another 2. So 2, and then cube root of 3 left on the inside. So here is the cube root of 3 left, and here is the cube root of 3 left. And then I just go ahead and I simplify. So 5 cube root of 3, and then 2 times 2 times 2 here is 8, so minus 8 cube root of 3. And these are like radicals now, so 5 cube root of 3 minus the 8 cube root of 3 will be negative 3 cube root of 3. So negative 3 cube root of 3. There's my final answer. What a time to be alive. All right, so now let's go on to the next one here, and let me just write this at the top of the page here. It is going to be here the 7t cube root of 9t to the 11th minus cube root of 24t to the, oh, nope, 243t to the 14th. All right, so there is the next one that I have right here. So let's go ahead and do that one. All right, so what do we have here? Well, we see that these two cube roots are not the same. So we have, well, we have cube root of 9. That's just cube root of 3 times 3. And then cube root of 243 will be, all right, so cube root of 243 will be cube root of 3 times 3 times 3 times 3, and then times 3. So you can see that here are 3 3's here, so one of them can come in front of the cube root. So we have 3 cube root of 3 times 3, or 3 cube root of 9. So this is going to stay the cube root of 9, and this one will become 3 cube root of 9. So we have 7t, and then cube root of 9, and then t to the 11th. All right, so 11 divided by 2 is 5, remainder 1. So this is t to the 5th cube root of t. Then minus, remember the cube root of 243 we just said was 3 cube root of 9. So 3 cube root of 9. And then we have cube root of t to 14th. So 14 divided by 3 is actually 4. All right, so, oh, excuse me there. So actually, you know what? I said cube root. So this actually should be 3 here. So what will that make this? This will make this actually. What will that make that? That will be 3 remainder of 2. All right. So that will be t to the 3rd, and then cube root of t squared. So this will actually be, what will that be? 4 remainder 2. So t to the 4th, and then cube root of t squared. So now, what do we have here? We see that what's under the cube root is the same in each term here. So we have cube root of 9t squared. And then we also see that we have 7t cubed. And then we have the, oh, well, actually, there we go. 3 remainder 2. So 3t cubed here. See, I divide it wrong on both of them. There we go. So, my apology, but I was a little bit distracted by the dust flying around in here. So, we have 7t to the 4th here. So, 7t to the 4th cube root of 9t squared minus, all right, so what do we have here? So, oh, actually, I was right, 4. I told you I was distracted by the dust flying around in here. It's like I can't even see anything through this dust storm. All right, so there we go. So that's still 4 here. So 4. So we have well, 3t to the 4th and cube root of 9t squared. So both of these terms are like terms now, because they are t to the 4th cube root of 9t squared. So we have 7t to the 4th minus cube root of 9t squared minus 3t to the 4th cube root of 9t squared. So then what do we have here? We have 7 minus 3 is 4. So we have 4t to the 4th cube root of 9t squared. So there's our answer right here. What a time to be alive. All right, let's try another one here today. So now that the dust storm is gone here, maybe I can see the problem and get the division right on the first try here. So a squared b, and then we have cube root of 21a to the 10th, b to the 19th, plus ab squared cube root of 21 a to the 13th, and then b to the 16th. All right, so we see that these both have the cube root of 21, and I need to see if I can actually simplify that. So cube root of 21 is cube root of 3 times 7. I don't see a group of three threes or a group of three sevens, so I know that that can't be simplified any further. Then for the cube root of a to the 10th, well, 10 divided by 3 is actually 3 with the remainder of 1. So this becomes, all right, so a squared b cube root of 21. And now I have a to the third cube root of a. Then 19 divided by 3 is 6 with a remainder of 1. So we have b to the 6 cube root of b. Then plus the ab squared cube root of 21. And then for the a to the 13th, since 13 divided by 3 is actually a 4 with a remainder of 1, I have a to the fourth, and then cube root of a. Then for the b to the 16th, I have 16 divided by 3 is actually a 5 with a remainder of 1. So I have b to the fifth, and then cube root of b. All right, so this might seem like a mouthful here, but let's get it together here. All right, so both terms now have cube root of 21ab, so cube root of 21ab. And then what do I have here? So let's simplify this. A squared b times a cubed b to the 6. So that will be, well, a to the 5th and b to the 7th, and then cube root of 21ab, then plus ab squared times a to the 4th times b to the 5th, so a to the 5th and b to the 7th cube root of 21ab. So now I will combine the like terms. So, well, these are exactly the same. So now that means there are two of them. So we have 2 times the a to the 5th, b to the 7th cube root of 21ab. And there's our final answer right here. All right, there we go. What a time to be alive. All right, I hope that you're really excited about this next one here. It says rationalize and simplify. So if you realize here, what they're actually talking about specifically is to rationalize the denominator. All right, so if you remember what rationalizing means, it means that we want to get the square roots or any of the irrational numbers out of the denominator. All right, so the one way that we could do that in this case, or whenever you have square roots, is to remember that if you have the let's see, the difference of two perfect squares, a squared minus b squared, that's a plus b, a minus b, all right? Or a minus b, a plus b. So here is the thing here. If we want to get rid of the square root of 7, all we really need to do is square it, all right? So, because the square root in the squaring functions are inverses or reversing of each other, okay? So, what you multiply by is actually 1 plus the square root of 7. 1 plus the square root of 7. And these two are actually what people usually call, or the technical term is called conjugates. So they are the same binomial here, or two term expression, but with different signs here, 1 minus and 1 plus. Now, if you look here, then if I have 1 minus square root of 7 and 1 plus square root of 7, then I can actually say that's a difference of two perfect squares. So it's 1 squared minus square root of 7 squared, and 1 squared is 1, and square root of 7 squared is 7, and 1 minus 7 is going to be negative 6. All right, so just remember that's the trick that we're using to get rid of the square root or to rationalize the denominator here. So in the denominator now, we see that we have negative 6, and in the numerator, we have, well, 1 times, all right, 1 times all of this here. 1 times 1 is 1, and 1 times the square root of 7 is just square root of 7. So then another way to write this, of course, then would be, you could write it as 1 over negative 6 plus square root of 7 over negative 6 if you want, or just negative 1 6. All right, so you can bring the negative up to the numerator and the negative up here, so minus square root of 7 over 6. Or some people might even just not like the negative in the denominator, so they would just bring it up to the numerator and it would just be negative 1 minus square root of 7 over 6 like that. So this is okay, this is okay, this is okay. All right, so any of them would be all equivalent answers for our purposes here. All right, meaning that if you found the decimal approximation, they would all be numerically equivalent. All right, so let's try another example here of rationalizing and simplifying, or specifically, again, rationalizing the denominator. All right, so remember my pattern here. I have the a minus b times a plus b. That will be a squared minus b squared. So in this case, I have square root of 17 minus square root of 11. So I'll need to multiply by square root of 17 plus square root of 11 to get rid of the square roots and to rationalize the denominator. So square root of 17 squared is 17 and square root of 11 squared is 11. So this will be 17 minus 11 is 16. All right. So what do sorry, 6, not 16, 6. All right, there we go, 6. All right, so what do I have here? So again, if I multiply by square root of 17 plus square root of 11 over square root of 17 plus square root of 11, these two are called conjugates. So these are called conjugates. And when I do that, the denominator is just equal to 6. So I have 6 times the square root of 17 plus the square root of 11 over 6. And then I see that here, if you remember in the last example, I distributed this 1 here, which wasn't actually even necessary because 1 times 1 plus square root of 7 is just 1 plus square root of 7. But here, I could distribute the 6, but I don't need to because 6 divides out. 6 divided by 6 is 1. So I'm left with something that doesn't even have a fraction anymore. So this is square root of 17 plus square root of 11, and there's my final answer right there. What a time to be alive. I hope that you really enjoyed this because we're not done yet. I have more for you. And here's another one today. All right, so we have 5 square root of 21 over square root of 21 plus 4. Remember, again, I really want to get rid of the square root in the denominator. That's what I mean by rationalize and simplify, or rationalize the denominator and simplify. So remember, I have a squared minus b squared is a minus b, a plus b, and here I have the square root of 21 plus 4. So I need to multiply by square root of 21 minus 4. So we have a square root of 21 squared minus 4 squared. So square root of 21 squared is 21. Square root of 4, what, square root of 21 squared 21, and then 4 squared is 16, and sorry, I just said square root of 16 and 4, but it's already 4, so 4 squared is 16. All right, then 21 minus 16 happens to be 5. All right, so that's 5. So what do we have here? Well, I'll multiply by the conjugate. So square root of 21 minus 4, square root of 21 minus 4. And so we see that the denominator here, we just multiplied out and got 5. So we have 5 square root of 21 times square root of 21 minus 4 all over 5. And similarly to the last example, the 5s will divide out. So we don't even have a denominator here anymore. So we have the square root of 21 times the square root of 21 minus 4. Then I need to distribute the square root of 21. So square root of 21 times square root of 21 minus 4 times the square root of 21. And square root of 21 times the square root of 21 is just 21, because square root of 21 is times square root of 21 is square root of 21 squared, and that's 21. Or if you wanted to multiply the 21 and the 21 together, all right, that would give you the square root of 441, which is still 21. So either way is fine for us because we're just talking about numbers here and it's not that big of a deal for our purposes today. All right, so minus the 4 square root of 21, and there's my answer, is right here. All right, what a time to be alive. All right, so of course, we're not done. We have some harder ones left, just 2 more difficult examples. Actually, I won't even say they're difficult because you're a pro at this by now. If you've been watching this video, you should be able to do all of these types of problems. So just remember how to do all of these for the rest of your life. All right, so here in this problem it says rationalize and simplify. So remember that means to rationalize the denominator. So that means to get rid of the square roots in the denominator. So we're going to use the same trick. A squared minus b squared is a plus b, and a minus b. So we have square root of x minus square root of y, which means we need to multiply by square root of x plus square root of y, which gives us over here square root of x squared minus square root of y squared. Square root of x squared is x, and square root of y squared is y. So we know that this will end up being x minus y. All right, so let's multiply by the square root of x plus square root of y over square root of x plus square root of y, because those are what we call conjugates. All right, conjugates. And then we see that the denominator was already going to be x minus y, and the numerator 4 times the square root of x plus the square root of y. Here we do need to distribute the 4 because none of the factors will cancel out. So we have 4 square root of x plus 4 square root of y in the, and I'll make that look more like a y so you don't think it's a 4 in the numerator, all over x minus y, and there is the final answer right there today. All right, let's try one last problem here. So this one happens to be a problem where it's a little bit more difficult even, but not impossible. All right, I don't want you to think any of these are impossible because you can do anything you want in life if you put your mind to it. All right, don't shortchange yourself. So we have a squared minus b squared is equal to a plus b times a minus b. So now we see that here is a minus, so we'll need to multiply by the conjugate, which is square root of 2x minus, and then, well, plus 3 square root of z, so square root of 2x plus 3 square root of z. The one thing that I do want you to notice is that the x is under the square root, so it's not square root of 2 times x, it's square root of 2x, all right? So these are not the same, but the one that I have here has the x under the square root. So sometimes it is a little bit hard to tell if the print is small or if you're using Internet Explorer or something like that where things won't show up properly, then you might have a little problem seeing that easily. But the x is under the square root in this case. All right, so what do you have here? We have square root of 2x minus 3 square root of z, and then times square root of 2x, and well, let's make that one plus and that one minus, just so that we go ahead and follow the same format that we have up here, although it doesn't matter which order those factors are in. All right, so of course it doesn't, because the multiplication here is well, commutative, all right? So let me just make that z a little bit more easily visible for you. All right, so there we go. That's much nicer, right? So this here then is square root of 2x squared minus 3 square root of z squared. So square root of 2x squared is 2x, then square root of z is z, and then 3 squared is 9, so we have 9z. All right, so now that was really the difference between the 3 being under the square root and not, all right? Because 3 squared is 9, and square root of 2 squared is just 2. So now we know that that's what we have in the denominator. So let's go over here. We have square root of z times square root of 2x plus 3 square root of z all over 2x minus 9z. Now in the numerator, we need to distribute. So what do we have here? Well, we have square root of z times square root of 2x plus, all right, so we have 3 square root of z times square root of z all over 2x minus 9z. Now, let's multiply what's under the square roots together. So z times 2x is going to be, well, all right, so that's square root of 2xz plus 3 square root of z times z is z squared, then all over 2x minus 9z, and then we have, all right, so we can see that square root of z squared is just z, so square root of 2xz plus 3z all over 2x minus 9z. So there is our final answer, although you can see that the answer that we have over here has the square root of 2xz and 3z added in a different order, but of course that is fine. So we have 3z plus the square root of 2xz all over 2x minus 9z. All right, there you go. So there is our final answer. I hope that you really enjoyed this video on adding and subtracting radical expressions, and unfortunately this may be the last video on this type of algebra topic here for a while, but I hope that you enjoyed it, and until next time, I'm signing out.